Good afternoon all. So we are running to the last lap of the day one of EFCS conference, and this will be the oral presentation session by 6 research scholars across the different part of the country. And I invite 3 judges, Professor Sebastian Peter from JNCSR, and Professor Nonappa and Professor Murugavel sir to occupy the front seats for judging the presentation. And each participant will be getting a total of 10 times 8-minute presentation and 2 minutes for the interaction. And I humbly request all the participants, all the presenters to strictly stick on to the time. The first presenter will be Ms. Anjali C from University of Calicut. I request Anjali C to come forward and have the presentation. Please stick on to the time, 8 minutes plus 2 minutes interaction. Anjali.
Okay, good afternoon to one and all. Here I am going to discuss about calcium chloride incorporated definoxide PVA as a greener solvent for atmospheric water harvesting. Let us begin this photograph. These are 12 years before and after satellite images of some of the regions of our planet, which is showing how the human changed our planet for a short duration. And the main reason is that owing to booming population, pollution has now reached its extremes, and pollution is now rising to a level that is nearly irreversible. And of course, this photograph remained as that the Earth is not exclusively for our use. We have the responsibility to conserve it for the future generation also. So that UN proposed a sustainable development system, and these are a collection of 17 interlinked objectives designed to serve as a shared blueprint for peace and prosperity for people and the planet now and into the future. And out of these 17 SDGs, we are contributing on the 6th one, that is clean water and sanitation. Because during the journey from 20th to 21st century, the water scarcity water consumption of mobile community has become doubled with respect to population, and it is estimated that about 4 billion people live under conditions of modest water scarcity for at least 1 month in a year. According to UNICEF, half of the global population could face water scarcity challenge by 2025. So, the freshwater scarcity motivated the researchers worldwide to explore and exploit the potential of alternative freshwater sources. Let's have a look on to the distribution of water reservoirs on Earth. Of course, the major source is sea, so the most adapted strategy was desalination. But they have some limitations, and the major one is which is feasible in coastal areas and are generally inaccessible for arid regions. So we need a solution which is applicable for everywhere in the world. The inspiration from the nature, still the case of the Dipin in the Namib desert, they were collected water from the fog for their survival. So the solution is atmospheric water. About 12,800 trillion liters of renewable water available in the Earth's atmosphere, and which is present regardless of geographical and hydrological conditions. So, which is offers itself as an attractive and alternative freshwater sources, which become considered as a helpful strategy for decentralized water production, meeting the challenges of long-distance transport or delivery of potable water in rural areas. And the existence of water in the atmosphere are mainly divided into 3, and we are focusing on the third one, water vapor in the air. And this moisture-based atmospheric water harvesting again divided into 2, sorption-based methods and condensation-based methods. Here we are going to discuss about the sorption-based atmospheric water harvesting. The main mechanism behind this sorption-based method is that there is a hygroscopic material which is able to collect water from the atmosphere, and by giving a heat energy which will dissolve the collected water. And these are the conventional water harvesting materials that we have been used. These have some limitations, like that due to a high water affinity makes the release of harvested water challenging, and high energy consumption for desorption. So here is the task how to release the collected water from the material. Here comes a new area, that is solar driven atmospheric water harvesting. In this method, the solar energy is converted into heat energy, and which drives the desorption of water in the sorbent, and which is the greenest and economic strategy. The main material used for this are carbon-based materials, and out of this carbon-based material, especially the miracle material of the era, graphene finds significant importance in atmospheric water harvesting due to their outstanding photothermal conversion efficiency. So in our work, we have synthesized the graphene oxide, calcium chloride incorporated graphene oxide PVA gel as a super absorbent material for atmospheric water harvesting. This is a synthesis procedure that we have done. And on to the characterization part, the clear spectra, we can see that the peak at 2,946 cm corresponding to CH stretching in PVA is dominant in all the composite, evident the successful incorporation of the components. And the three-step degradation stages in the TGA pattern will also support this statement. And in order to study the morphology of the material, we have done the SEM analysis. In the SEM images of the material, calcium chloride incorporated reflective PVA gel, the material is highly porous in nature. So this porosity will induce improved water harvesting capacity. And the decrease in contact angle measurements after treating with the hygroscopic material will also provide more water harvesting capacity of the material. And this is the range setup that we have, and this is the schematic representation of the experiment setup that we have. And we are the first one introducing bottom weighing in atmospheric water harvesting. For that, the sample were suspended from a balance and weight is monitored, and the sample is kept inside a compartment, and the compartment is continuously supplied with air with different humidity using different saturated salt solution. And the gain in weight and the humidity inside the compartment were continuously monitored using lab-based software, and these are the data that we have obtained. Out of the 6 systems that we have synthesized, the one with the 5-8% calcium chloride loaded sample show good water harvesting capacity of 0.83 gram per gram of 2-hour water capture, and the same material is exposed for 24-hour water capture, and we have obtained about 1.9 gram per gram of water harvesting efficiency. And in order to study the humidity and study the effect of humidity and temperature, we have done the experiment in different temperature and humidity conditions, and we can see that by increasing temperature and humidity, the water harvesting capacity of the material were also increased. And this is the outdoor experiment that we have conducted. For the outdoor experiment, the samples were packaged in a nylon mesh bag, and which is kept outside the campus during night time for direct contact with the moisture, and daytime they were collected and placed inside this prototype. And when the prototype is completely sealed and placed under direct sunlight, when sunlight falls on the material started to dissolve the collected water, and the collected water was evaporated and condensed on the sliding edge of the prototype, and that is collected. And in order to study the reusability of the material, we have repeated 10 water capture release cycle, and it will show good results. And in order to check the purity of the collected water, we have tested the pH and the resistance of the collected water, and it is combined with the different water samples, and we have obtained comparable with the drinking water. So we can say that the collected water can be used for drinking purpose. And let's conclude, the cell is prepared for atmospheric water harvesting. The one with the 5-8% calcium chloride loaded sample show a maximum water capture capacity of 0.83 gram per gram at native humidity 75%, and the gel presents a stable water harvesting performance of up to 10 capture release cycles. And the collected water can be useful for drinking, industrial as well as agricultural purpose also. So indoor is this prime features like low weight, flexibility and portability, which takes this water harvesting system one step further to practical application and commercial production. Thank you.
Over to the judges for the interaction.
You show the pH of the drinking water to be certified on site. What drinking water is this?
That is bottled mineral water.
Okay. So, you said it goes to 10 cycles back and forth. Now, if you are going to use salty water, sea water, do you think contamination of 10 cycles, the weight of the gel is increased?
Weight of the gel, yeah, then it depends. Actually, we are dealing with the samples that for atmospheric water, moisture only, standards only, not for free water.
I wanted to ask you, there is calcium that is coming out or not?
Yes, we have done ICPMS analysis of the collected water, and the value obtained is around 110 ppb, which is within the permissible limit. The permissible limit is 600 ppb.
So, 510 ppb was what about 200 ppb? Is it decreasing with time?
That's not secret. Actually, check only the ppb of collected water only.
No, once you collected, you have done 6 cycles. One time you collect this time. Next time, what is it?
We have checked for only one cycle sample. And actually, in the case of 2-hour water capture, there is no leakage. The leakage is, somewhat leakage is taking place only in the case of 24-hour water capture.
My last question, for a family, how much of this material is needed to get 10 liters of water?
The large scale production of this material is somewhat difficult, but when we can find another good material, we will can be large scale production.
How much of material is needed?
We have, so this is the large scale production. We have done the large scale production in, as far as possible in our lab also.
Thank you.
So you will use the four compounds, magnesium chloride, calcium chloride, sodium hydroxide, sodium chloride. Right?
No, sir, calcium chloride only.
But you do not use other.
Different composition of calcium chloride, 1 to 6 to 8% of calcium chloride.
So, and then you got best value 5-8%.
Yeah, 5-8%.
The 5-8% is you are talking about based on the input given.
Yeah.
You told that ICP you have done.
ICP I have
What
done
is
for
the
that.
actual value of ICP?
ICP is that we have done for the collected water, sir.
Original one.
Sir, I am going to present a part of my research work, design and development of potentiometric sensor for selective determination of ultimately groundwater samples. And I am doing my research work under the guidance of Dr. Soumya from St. Joseph's College, Devagiri. So these are the objectives for the present work: to develop a simple, portable and economically viable arsenic sensor by means of arsenic ion imprinted polymers using molecular imprinting technology. And this arsenic imprinted polymer is used for fabricating potentiometric sensors and for its sensing studies, and then optimize the analytical parameters such as sensitivity, selectivity and response time, and real sample analysis using natural water. So why we selected arsenic? Because according to International Agency of Research on Cancer, classified arsenic and arsenic containing compounds as carcinogenic to humans, and these are some of the sources of arsenic exposure and related health consequences. So we selected potentiometric sensor for sensing arsenic in real sample analysis. So why we selected potentiometric sensors? Because potentiometric sensors are robust in construction, and it is portable and compact size allows it for on-site analysis using analysis in remote locations, and it is also showing rapid response time, and thereby we can effectively use this arsenic potentiometric sensor for sensing arsenic in natural water, especially in remote areas. So these are the latest literature reports regarding arsenic-free ion imprinted potentiometric sensors. And the second one is showing a vector linear working range of ranging from 5 into 10 raised to minus 8 to 1 into 10 raised to minus 1, equivalent of 3 into 10 raised to minus 8 moles per liter. And we selected a solid contact based potentiometric sensor for arsenic using a flexible and low cost lightweight carbon core as the solid contact material, and it is then the membrane was developed on the surface of the carbon core by using an optimized membrane cocktail solution, and later it is then coupled with reference electrode using an ion analyzer to get the calibration plot. Next is the methodology, results and description. So first task is to develop an ion imprinted polymer or arsenic ion imprinted polymer as the answer for developing this sensor, and we implemented molecular imprinting technology using sodium isolate as the template, MA as the functional monomer, and EGDM as the cross linker, and we get a template imprinted cavity, and later this template was removed by simple solvent washing. And similarly we prepared the reference non-imprinted polymer but without the addition of sodium isolate during molecular imprinting technology. Then we characterized the IIT and LIT using FESM. The surface morphology was found in this images A and B. Then we did the EDS analysis, and is just to confirm the imprinting of arsenic in the polymer matrix. Then after that, we did the FTIR analysis in order to confirm whether arsenic is completely removed from the imprinted cavity or not. And the absence of peak at 669 centimeter inverse after this template inverse confirms the complete removal of arsenic from the matrix. And the presence of asymmetric and symmetric carboxylate vibrations are found at 1637 centimeter inverse and 1459 centimeter inverse in the arsenic imprinted IAC, and this confirms the existence of a bidentate phenide bond formation between arsenic and MAA moiety. Then after that, we prepared the membrane cocktail solution containing the iron core, and it is then broadcasted on the carbon fixed area of carbon plus and is then air dried and later coupled with reference electrode to obtain the calibration graph, and this is the self-representation. So the above calibration graph is reached by optimizing the membrane cocktail solution. So first we optimize the MIT to TOAB ratio as 1:1.33. Then we optimize the MIT to PVC as 1:1.33. Then task spacer was optimized and it was 200 micrometer of DPHs. Then move on to optimization of analytical parameters. The potential stability and response time was studied in a decade-based conformation range from 10⁻11 to 10⁻², and we optimized the response time as 3 minutes. Then sensitivity of the developed IAC sensor was checked by comparing with NIT membrane and blind membrane, and the results show that IAC is showing good sensitivity with a limit of detection of 1:10⁻12 molar and a slope of -18 millimoles. Then we did the selectivity studies using massive potential method, and these are the interfering agents we selected, and the results are tabulated, and this shows the selectivity factor is considerably smaller than unity, and this confirms the developed sensor is selective for arsenic over the selected interfering agents. Then we check the analytical performance of sensor with respect to changing pH ranging from 7.4 to 12.151, and better and identical response characteristics is observed in the pH range of 9.4 to 11.5, and we optimize the pH as 9.4 to 11.5. So these are the analytical parameters we optimized, and based on the selectivity studies, we did the recovery analysis for the selected for the developed arsenic sensor, and the recovery results are tabulated, and this shows a good recovery result. And this shows better good recovery results for arsenic sensors in remote locations. So we can conclude that a novel procedure was introduced for the preparation of arsenic imprinted polymer using molecular imprinting technology. The developed solid conduct-based arsenic-free sensor shows a lower limit of detection among the current available potentiometric sensors. The high sensitivity, selectivity, flexibility, and portability of the developed arsenic sensor can reliably be used for field modeling. Thank you.
Thank you, Anjana, for the presentation. Over to the judges.
We just asked them to check whether arsenic is present or not. Actually, we send another slide.
You are only worried about presence of arsenic, right? Yeah. Any other molecule based on the data, anything can be expected to be?
Carbon will be good.
Okay. What else in that range? In that range, what else you can expect? What else you can expect? Did you ask them? They only give the arsenic, right?
Yes. Okay. Actually, send that sample.
Okay. One more point is, you have final conclusion, you mentioned arsenic 3+. Is any way you can find arsenic 5+ also possible?
Arsenic 5+ is possible, but here the chemical response is around -18 millivolt, and it shows the 3 electron transfer, and thereby we can conclude that it is arsenic 3+.
Thank you for the presentation. Since in the beginning you mentioned that your goal is to sense, and at the end also you said that it can be used to monitor in the remote location. And what is the required response time? What is currently known? And for sensor response time? Because if you want to monitor, there might be some requirement, right? If you want to real-time monitoring. Yeah, the response time, you mentioned that some of the potentiometric sensors have 50 seconds. Yeah. And how about your sensor response time?
Ours is 3 minutes.
3 minutes. Yeah. And how can it be improved? Do you have any idea? Or are you working on that? Is 3 minutes good enough, or do you need to reduce?
Actually, we expected below 3 minutes, but
Yeah.
we obtained only 3 minutes. And 8% is changing around 2 to 10, 40 seconds.
Thank you.
One quick question from me. Did you check arsenic containing water from the field?
No, sir. Actually, we want to check selectivity studies on some other ionic aspects. After that, we can check for real sample analysis. Some are doing that.
Arsenic ion imprinted electrodes have been already used in these kinds of context. Are you having any improvement in comparison to those similar materials?
But literature reports, sir. Actually, the literature report is saying about liquid contact based adhesive, and we are using solid contact based adhesive because sensitivity can be improved by using the solid contact based adhesive.
Thank you.
Myself, Athulya K R, research scholar in the Department of Applied Chemistry, CISAT, under the guidance of Dr. Anjana K R, Professor, School of Chemical Sciences, Mahatma Gandhi University, Cochin. Today I am going to present a small work which is entitled as Spectroscopic Investigation of the Stability of Carbon dots derived from polyethylene glycol. We all know what are carbon dots. They are spherical nanoparticles with size less than 10 nanometers, and they are known for their properties like biocompatibility, non-toxicity, and most importantly, highly fluorescent nature. And these properties can be attributed to various applications, especially in the field of biomedicine, like bioimaging, drug delivery, etc. Mainly, there are two approaches for synthesizing carbon dots. That are top-down approaches like electrochemical arc discharge, laser ablation methods, or bottom approach methods like ultrasonic hydrothermal or microwave pyrolysis. So in my work, I chose microwave assisted synthesis because it has its own advantage. The most important thing is that it is very economical in nature, and time for reaction is very less, and it is greener, and most importantly, the carbon dot form will be uniform because it gets uniform heat distribution by synthesizing carbon dots by a microwave assisted method. And the precursor chosen for synthesis is polyethylene glycol. Polyethylene glycol, we all know they are a linear long chain polymer which is non-toxic in nature, and it is highly soluble in water. And the most important thing is that they have high stealth property. That is the property to repel blood proteins. So it will ensure prolonged blood circulation time, which is really useful in the case of biomedical application. So moving to the experimental part, as I mentioned, it's a very simple method, a microwave assisted method. So first we take polyethylene glycols of different molecular weights. Say 200, 300, and 400. And the experimental part is very simple. Taking 10 ml of each of these polyethylene glycols in an RB and heating in a microwave oven at a power of 432 watts, and we will get fake carbon dots by analyzing the color change from colorless liquid to dark brown. So the time for color change from the colorless liquid to dark brown for each of these molecular weights varies. For PET 200 it was 10 minutes, and for PET 300 it was 30 minutes, and for PET 400 it took almost 20 minutes. So, for example, for PET 200, the color change is represented here in this picture. First, it was a colorless liquid, and then to a light yellow color, then brown, then dark brown, which indicates the formation of carbon dots. So, these carbon dots, which is stored in a storage vial at room temperature, and even after 60 degrees Celsius, 60 days of storage, it remains the same. There is no bleaching out. So, which visually we can save stability. So this is just a picture. Under daylight, it was a dark brown colored solution. When it is viewed under UV light, we obtained blue fluorescence. So fluorescence is the most important property for carbon dots. Moving to the characterization part, First, EFCS Tetra, the functional group analysis was done using EFCS Tetra. The red colored curve shows PEG 200 carbon dots, and the black colored curve shows that of PEG the corresponding precursor. So the precursor and the carbon dots almost have similar FTIR peak, but for the carbon dots there is an extra peak at 1740, which is of the carbonate stretching frequency, which also indicates the formation of carbon dots. Comparing just the FTIR spectra of 3 carbon dots from 3 molecular weights, we can see they are all similar because they are from same precursor, only molecular weight is changed. So optical characterization of the carbon bonds we can confirm through UV visible analysis. So the red colored curves is of raw pegs, and the black colored curves of the carbon dots. So the raw pegs from the picture itself, it is clear that there is no much UV absorbance. But on the other hand, the carbon dots have well-defined peaks in the range of 240 nanometers, 240 to 245, varies from PEG 200 to PEG 400. So upon storage day 1 to day 50, there is nothing much change in the wavelength of the UV spectra. So we can, from the UV analysis itself, it is clear that the carbon dots are stable. And next one is fluorescence. From the figure itself, it is clear that it shows blue fluorescence emission. And we took the fluorescence spectra when it is excited at a wavelength of 350 nanometer. For PEG 200, the fluorescence was almost negligible compared to the corresponding carbon dots. The carbon dots of PEG 200 gave an emission at 455 nanometer, and for 300 it was 452, and for PEG 400 it was 451. And upon storage of 60 days, the same wavelength is for emission is shown, but intensity is reduced a little bit. And this is just a comparison of PEG carbon dots in day 1 and day 60. The intensity order that followed in the same order of day 1 and day 60. So another thing is that carbon dots have excitation dependent fluorescence. That is, upon different excitation, they show different emission. So when PEG 200, it was excited from 300 to 380 nanometer. The emission was reduced from 448 nanometer to 470 nanometer. Similar is observed for PEG 300 and 400 carbon dots. Next one is the size analysis. It was done using DLS technique. The hydrodynamic diameter was found for all these carbon dots under 10 nanometers, and it is summarized in the table. So upon storage for 60 days, there is no much increase in size. So we can see that there is no aggregation in the particles, so carbon dots are stable. Next one is theta potential analysis. For carbon dots, it is said that negative theta potential value is stable for carbon dots, and it is characteristic for carbon dots. And we obtained negative theta potential values for all the carbon dots. And upon storage for 50 days, they maintain the negative theta potential values. So in conclusion, we could synthesize carbon dots using simple microwave assisted method, and it is found that the molecular weight has an effect on the properties of carbon dots by theta potential as well as fluorescence measurement, and all these carbon dots found to be stable upon storage even at room temperature. Thanks.
Can you just tell me what the difference between carbon dot and carbon nanoparticle?
Carbon?
Nanoparticle.
Carbon dots are specifically, they are family of carbon dots. They have size less than 10 nanometers. Carbon nanoparticles may have more than 10 nanometers.
More than the size. More than the size, is there anything else different? Other than the size, is there anything else which is different between the two? Can you go to your IR quickly? IR. Look at this interest. If we take just carbon nanoparticle and let it IR, would that look like this or different?
Depends upon the precursor we make the carbon dots. Okay. For polyethylene glycols, and that's why we got C double bond or stretch carboxyl group. So that's why C double bond group is formed upon carbon dot formation. So it depends upon the
carbon and carbon nanodot. Even another carbon should be another area. Do you get any big?
no, there will be no.
So what's the difference?
The functional groups are different.
One thing notice that you observe many based on the data. Cochin you say the characteristic nature. Where are the references? On what basis you say that?
Literature survey.
Thank you for a very clear presentation. And I'm wondering whether you can tell a bit more about what type of microwave did you use? Is it a domestic kitchen microwave or is it controlled?
Just a domestic.
Okay. Secondly, what is the conversion efficiency of PEG to quantum dot? Is it 100% or is there still not PEG remaining?
Maybe there will be lots of things remaining. Sometimes if you take DLS, sometimes we get more size than expected one. Maybe it's due to unreacted polyethylene glycol surrounding the carbon dot. So there is chances for polyethylene glycol unreacted remaining.
Thank you.
Carbon, I have a question here. The question is that normal kitchen microwave acts on water. It acts on water, H2O. Okay. Here you have used a polymer. Okay. Now my question is it really acting on the polymer or is it acting on something else to do this chemistry?
Polyethylene glycol itself has groups like hydroxyl groups. So it's not water, but upon microwave radiation, there is chances for oxidation and I think if water is there, there will be more time is needed for converting this to polyethylene glycocarbon dots. Maybe water will take time to boil and maybe water content will increase the time of reaction.
What is the microwave doing to water? Why is microwave?
To reduce the time of reaction. Okay, role of water in microwave?
What is microwave doing to water?
It will the rotational.
Your molecules rotate now? Your polymers rotate?
Thank you.
Good evening all. Welcome to my presentation. I am Dhanyasree, research scholar under the supervision of Dr. P.M. Sargura Begum and Dr. Yusuf Sharwat in the Department of Applied Chemistry Research. Today I am going to discuss a part of my research work. The topic entitled The Fabrication of Eco-Friendly Silver Nanocomposite Sensor Filling Source, the Removal and the Selective Colorability Detection of Mercury in Aquatic Environment. In our solar system, Earth is the only planet that supports life, that is the presence of water. Therefore, the water is essential for the well-being of all the living organisms. The access of clean water is a basic human right by the international organization and governments all over the world. In India, government takes several initiatives to improve the quality of water. Unfortunately, there is no better wastewater management system or strict rules or penalty against the misuse of water. These are some newspaper reports that show how drastically the water pollutions are increasing in India year by year. And we can classify the pollutants as inorganic pollutants and organic pollutants. So in my work, I mainly focus on the inorganic pollutants like heavy metals. These are some heavy metals, and there is a permissible amount of Indian standards available for drinking water. If it exceeds, the water becomes contaminated. From the list, we can see that mercury that is only in a nanomolar concentration. Therefore, the detection of mercury is a highly challenging one. And then next we want to discuss how the mercury is released to the aquatic system, mainly by two processes. One is natural process by the volcanic eruption or the coal combustion, or another one is the man-made process like industrial exploration, mining, the use of pesticides in agricultural fields, urbanization, etc. And all these contaminated waters are easily released into the neighboring aquatic system, and thereby there results the concentration of heavy metals that increases than the permissible limit. Therefore, the detection of mercury by using so many sophisticated techniques like stripping voltammetry, cold vapor atomic effect spectroscopy, etc. But these are highly expensive and also time consuming. Therefore, we want to switch on the next alternative technique by using colorimetric method using a simple spectrophotometer. When comparing to a simple spectrophotometer, that is less expensive and gets quick result, and also naked eye detection is also available. For the colorimetric detection, I use it to prepare silver nanoparticles. That next, green method using photoscanners, that is a novel source, that is a medicinal plant widely seen in Kerala. Here we can see that the pale yellow extract that is instantly colored within 10 minutes to brownish yellow with the presence of silver nitrate, that is a precursor. And this is the UV absorption spectra that confirm the presence of silver nanoparticle, that is a 430 nanometer. And this is the FTR spectra, and from the SEM analysis we can see that is a spherical in shape. From the DLS analysis, we get the hydrodynamic diameter, that is 50.5 nanometer, and EDAC is also there. Therefore, using this silver nanoparticle, we can detect mercury by the simple mechanism that the silver nanoparticle is added to the mercury 2+ ion solution. There is a color change from brownish yellow to pale yellow, and there is an instant color change to colorless, that is the formation of alloys. Here, why we use silver nanoparticles? If we use silver acid, here we can see that the electropotential value of silver and the mercury, that is the difference between them is very less. If we change it to nanoparticle size, the electropotential value of silver nanoparticle becomes lower and the difference between them is high. Therefore, this is a fast favored redox reaction takes place. So, using this silver nanoparticle, we want to prepare a smarter material using greener one. So, I choose titosine and starch that both have green polymers. By optimizing their concentration, I get a better property filling, and the incorporation of silver nanoparticle into it, I get a polymer silver nanocomposite filling. And this filling is cut into dip in the mercury 2+ ion solution, and there is an instantaneous color change. From the UV absorption spectra here, we can see that after the addition into the Hd 2+ ion solution, there is a disappearance in the peak at 430 nanometer. This is the analysis of silver nanocomposite film. All the steps I analyzed the property of the film by swelling studies, and the addition of silver nanoparticles to the composite film is analyzed by water contact angle. And from the UV absorption analysis of the silver nanocomposite here, we can see that the peak at 430 that is not remains in there is no shift in there. This is FTL spectra, and the TG analysis from the study we get a peak at 30 degree, that is the silver nanoparticle in a 1-1 plate. For the quantification, I used the silver nano composite into a concentration of 0 ppm to 60 ppm Hg 2+ ion solution. Here we can see that there is a linear decrease in the intensity of the absorption of the silver nanoparticle in the composite film. This is the calibration graph. And the real-time analysis is also done with the neighboring water bodies near to the PET canvas. Here we can see that there is no shift in the absorption peak of the silver nanoparticle in the composite film. That shows the absence of mercury in the neighboring water bodies. And the spiking method is also done with the drinking water is added with 1 ppm to 30 ppm of the mercury solution. Here also we can see that there is a linear decrease in the absorption intensity. And this is the colorimetric photograph of the composite film. And after it is dipped into the 100 ppb solution, there is a color change to pale yellow. And after it is dipped into the 100 ppm solution, it becomes decolorized. And this is the UV absorption spectra shows there is a disappearance of the absorption peak after it dipped into the 100 ppm solution of Hg2+. The selectivity of the composite film is highly important. So I done the same experiment with the other elements. Here we can see that mercury shows higher selectivity towards the composite film than other metals. And the limit of quantification that is about 1.1 ppb, and the limit of detection that is about 0.39 ppb. Moving to the conclusion, I synthesized the silver nanoparticle in a greener method and SPR band of 430 nanometer and the spherical in shape. And the colorimetric detection of Hg2+ is analyzed with both silver nanoparticles and the nanocomposite film. And the limit of detection are almost about 0.39 ppb. When comparing the previous literature, it is a better value than others. The limit of quantification that is 1.18 ppb. And the real-time analysis is also done with tap water and drinking water from the PET canvas. And the capability of Hg2+ ion removal is analyzed by Hg analyzer. We get a better result, that is 99.29% of mercury 2+ ion is removed by using a single piece of composite film. Hence, the sensor film is highly effective for both oxidation and the removal of Hg2 plus ion from the aquatic system. These are my reference papers. Thank you.
Thank you, Dhanyasree, for the nice presentation. Good talk. So, how did you confirm any of this alloy formation? Mercury, silver. How did you confirm? You mentioned that mercury alloy, silver alloy formation, right?
Sir, there is a color change to transparent.
Color change is sufficient enough to say that alloy formation.
Sir, actually in previous reports, I searched that the SSM analysis method, if the silver nanoparticle is combined to the mercury, that shows some effect. So I send my sample to SSM analysis.
Okay. If it is forming, what is the bond between mercury and silver?
Okay, sir. Here, before the addition to the Hg2 plus solution, the silver is in Hg0 state. That is a redox coupled reaction is takes place. Here, Hg0 is combined with Hg2 plus. There is a shift that is Hg plus to Hg0.
So, mercury plus silver, what is the bond? Is it a covalent or ionic or what kind of bond is expected? What is it?
Ionic.
Ionic bond.
That's the problem. We call this alloy. Alloy is formed between two neutral atoms, right? Brass, all your alloys what you have are essentially, a solid solution of various metals. Okay? Now, the Fe2 plus goes to Fe0, that means the electrons are coming from somewhere. And just like that is coming from silver. If silver goes to silver plus, I have not heard of any alloy formed between ion and zero metal. So that formula will be corrected. Okay? Probably silver just leads to solution, and since silver is leached, color is gone. There's nothing to do with the alloy formation. This is my guess. I could be wrong. But definitely, an alloy is formed between an element and an element, metal and metal. Okay? So you can't have a cation combining with other metal to form an alloy. Okay? That was your question 2. What is the gas of bonding with the metal? Hey, tell me what is DLS? How does DLS work? Everybody should DLS. What is the principle?
So there is a light scattering.
When you particle size from there, right? How is the light scattering using particle size?
Continue that point. Suppose if it is forming an ionic bond, say for example, how the strength of bond? How you can consider the strength of bond between silver and mercury? Think about how it can be used for the release of, mercury. It may be stable, that is problem.
I want to know whether mercury 1 plus does it show if there is any sensitivity?
No, sir, I didn't check the Hg plus.
Methyl mercury, there is another form of mercury in water. Is it sensitive?
Actually, I think Hg2 plus is highly toxic, but it has the ability to transform to inorganic to organic forms easily when compared to Hg plus. So I choose Hg2 plus for the safety.
So imagine, let us say there is bulk silver particle, very large silver powder. Will it do this? Yes or no?
I think no.
Why do you think so?
Silver powder, like I showed that the electropotential value of silver and the mercury, that is the difference between them is very low. When it is converted into nano scale, then only the reduction takes place.
Mercury is from the amalgam with silver.
Yes.
I also will go, huh? So it can work.
Hello everyone. So thank you the organizers for accepting my abstract for this oral presentation. My name is Dipin. I am from IIT Bombay, working with Professor C. Subramanian. The title of my presentation is Plasmonic Synergism in Tailored Metal-Carbon Interface for Real-Time Single Molecular Level Sensing of PFOS and PFOA. So So the NGA presentation I have divided into three sections. In the first section, I'll be introducing about the carbon that we are interested, and slowly moving on to the surface platform, coupled emission platform, and finally the sensing application of this platform. So as you are all aware of the importance of carbon-based material, we have lots of carbon-based material, and most of the isotopes of carbon I have listed here. And this all carbons are comes under the category of soft carbon, which can be graphitizable at a high temperature. So there are certain kind of carbon material which you cannot graphitize even if you heat at high temperature, and that category of carbon is called hard carbon. So here we are interested on controlling the morphology of hard carbon using a chemical vapor deposition process. So in order to make the hard carbon, we have followed a CVD protocol. Here, in the CVD protocol, we have used a templated assisted protocol in which dendritic fibrous nanosilica is acting as the template. So the high porosity and the high thermal stability of silica is explored in the CVD process. So what is happening is that at high temperature, we are passing acetylene gases into the CVD chamber. So the acetylene gases will undergo homolytic or electrolytic cleavage. As a result, the carbon particles will diffuse into the pores of the DFNS. So we will end up with DFNS decorated with the carbon particle. So finally, we can remove the DFNS from the DFNS decorated carbon using a chemical etching using alkaline or acid media. So I have used alkaline etching to end up with the nanocarbon fluoride like this. You can see the uniform size distribution of this nanocarbon fluoride. So these are the term and hydrogen matches and the characterization of this NCF, which comes from the category of hard carbon, and the PXID also indicating the in-gas de-spacing in the system. So one more thing I want to say is that we can control the textural properties of this NCF by controlling the textural properties of DFNS. So we are ended up with the different varieties of NCF, and I am going to talk more about this small size NCF, which are in the diameter 75 nanometer. So the most peculiar property of this NCF is the light absorption ability in the NGA electromagnetic spectrum. So inside I have shown the UV visible absorption of this NCF. So it is having a good absorbance in the entire solar spectrum. So this property of NCF is used in the fluorescence platform. So in fluorescence technique, we have lots of limitations like isotopic patterning and the sensitivity problem, the photo bleaching, etc. So in this platform, we are trying to introduce another fluorescence-based detection called surface platform coupled emission. I don't have time to explain the fundamentals, but the idea is very simple. We are enhancing the fluorescence property of a fluorophore in presence of a metallic nanoparticle. So depending upon how much plasmonic constraint we are giving or how much electromagnetic hotspot we are generating, we can enhance the fluorescence property. So this SPC platform is high directional as well as highly polarized, and we then get a high percentage of collection of fluorophore from the system. So this is the experimental setup that we used in the study. So in this direction, we are incorporating the dielectric carbon with the plasmonic material so that the plasmonic system will be trapped in the NCF-based dielectric system. So whenever it absorbs some amount of energy, the plasmonic system confined in the energy in the optical cavities of the NCF will show better performance. So we have decorated different types of metallic particles on the surface of NCF like silver, gold, and silver gold hybrids. So the idea is we have used a frugal solar illumination for the decoration of different metallic nanoparticles on the surface of NCF. So we will end up with the different types of plasmonic system on the NCF. We have studied some kinetic dependent studies as well on the surface. If it depends on the different time duration, we can control the size and the properties of the metal decorated NCF. And these are the characterization. And without compromising the absorption property, we can explore this material for SPC application. So we have utilized different types of interfaces for the better enhancement like cavity, extended cavity, and spatial. So what we observed is that this hybrid NCF system at 10 units of solar illumination is showing better performance in the SPC enhancement, around 1,500 for the SPC enhancement we observed. So this remarkable high SPC enhancement is definitely highlighted because of the small size of the metal nanoparticle or the probable combination of metallic NCF hybrids. So these are some literature that how the SPC enhancement is reported. So now we are using this high-fold SPC enhancement for the sensing of emerging organic contaminants, PFOS and PFOA, and this material is electrochemically inactive at the same time optically inactive. So we cannot do a simple sensing using for this particular material. So we have the importance of this sensing is that this material having lots of health impact, and most of the countries banned the production of PFOS and PFOA and limited the production of this material. So these are the existing sensors available, but when we are using the fluorescence technique, we cannot move on to WHO stipulated limit. It's around 70 parts per trillion. In fluorescence, we will end up with 0.1 micromolar or 1 micromolar limit of detection. So we have understood that there is a good probable interaction between the rhodamine as well as the PFAS material, and this further proved by the theoretical calculations. And we have studied the material in the SPC platform. We have studied the performance in the SPC platform, and what we observed is that within the SPC platform, we can do the detection at parts per trillion that is comes under limits of world actually, the actual limits of detection. So for PFOS, we have observed 0.5 ppb limit of detection. For PFOA, it is 0.414 ppb detection. So in addition to that, we have replaced the convex optical system by using a mobile phone camera, and we have captured the emission, and we try to correlate with the luminosity values, and these are the mobile phone images that we obtained from this color graph software. So we have understood that both PFOS and PFOA can be detected in the SPC platform by correlating the luminosity with the actual SPC enhancement we obtained. So in addition to that, we have carried out some real-time analysis, how this system is applicable for the real-time system, like in different water bodies. So we have explored that also for real-time applications. These are the conclusions. And thank you all.
Thank you, Dipin, for the wonderful presentation. Dipin, nice work. Because you were in a hurry and I could not get certain things. So, why you selected DFNS?
DFNS is a hard template, so we are expecting we will end up with a hard template, with a hard carbon. So usually to make hard carbon, hard template usually gives hard carbon.
So can you tune the size of the DFNS?
DFNS we can so whatever MCF I want shown is that based on controlling the dimension of DFNS only. So then we are doing the carbon.
So when you do the controlling, do you tune the silver and gold nanoparticle deposition also?
Actually, that process is after the preparation of MCF.
Yes. Yeah. After that, when different size of the MCF you
Yes, sir.
So that is also controlling the particle size of the silver and then gold or the deposition amount.
Actually, solar illumination is controlling the size of the particle.
Okay.
Yeah, and we have done with only one type of MCF.
And secondly, you also mentioned silver gold alloys also, along with the silver and gold. How did you confirm that?
We are confirmed from ADAP, elemental mapping. So if it's the Cochin, we can easily distinguish where is silver and where is gold. But in our case, in the ADAP elemental mapping, we are observing a homogeneous distribution of this.
Homogeneous mixture cannot confirm alloy,
I think we can confirm from diffraction pattern as well.
Have you done anything?
Yeah, we have done that. I haven't tested it.
Small scale evolution. The raw particles look too large in size. Are they inside your MCF channels or outside?
Some particles are in the ports of the MCF as well as some are in the surface. So we are just saying that it's anchoring over the
They can stick around when you do this all the experiments. Do they stick around or they can leach?
That's not leaching actually.
Okay.
Thank you.
I'm Jazeel. Thank you for being here today as I delve into my research on copper catalyzed oxidative sp2 cyclone purification of orthoalkynyl arenols for the preparation of fused fuels. I performed this work when I was employed as an Institution of Eminence Junior Research Project Fellow under the guidance of Professor Srinivasarao Yaragula, the School of Chemistry, University of Hyderabad. Currently, I am employed as a guest faculty at a host institute, Farook College. So, before I get into my work, let me give a brief introduction regarding heterocycles. As we all know, heterocycles play a major role in organic systems. It's unavoidable. In fact, this single heterocyclic molecule, a benzimidazole nucleus, has a wide range of activities, all the way from antimicrobial to antiviral and everything in between. So, it's no great mystery as to why over the past century, many organic chemists have developed many methods to access such heterocycles. Among these methods, catalytic CH functionalization is of particular importance while defining a carbon-carbon or carbon-heteroatom bond. Its importance lies in its incredible atom economy and its green nature. As I was hearing to this presentation throughout the day, a central theme that seems to occur was about waste reduction. Professor Stalashi, in his very illuminating lecture, talked about reusing protein waste. Right. Professor Pradeep also gave a very exciting lecture on research on atomically precise materials. Right. This stems from a researcher's need to reduce waste. In the very last session, Professor Sebastian gave a very innovative talk on sustainability. Right. So, in that regard, as an organic chemist, sp2-CH functionalization in general is an organic chemist's way of reducing waste because the number of co-products that form through CH functionalization will be very minimal. Our research group had previously reported a highly unusual thermal ring rearrangement of benzochromines which under PTC catalysis at elevated temperatures underwent a ring rearrangement to give their corresponding ethanol derivative. This work was published in OBC in 2018. Later, we came across a patent filed by G.C. King and co-workers in 2019, where they tested the feasibility of using such huge ceramic systems with a quaternary carbon in organic LEDs. This piqued their interest because if somehow you are able to instigate a CH functionalization on this alkyl carbon and generate a cycloether over here, you would end up with a similar motif. Also, such structures are reported in many natural products like Cannabidiol A and cannabidiol. So, with this idea, we propose our work, a CH functionalization of this sp2 carbon with the phenolic hydroxy group of the naphtol, generating a polycyclic framework which may have applications in material chemistry, namely OLEDs. So, after that, we performed an extensive literature survey and found that there are very few reports on sp2-CH cycloetherification of arenols or naphthols having a cyclic olefin at the ortho position. A few representative examples are mentioned here. Then we started our research. We explored different reaction conditions to find an optimal, best ideal condition to facilitate our required conversion. Based on the information we gleaned from previous reports, our first attempt was with DMSO, which at 140 degrees Celsius did not yield any product. Introducing an acid to the reaction medium generated promising results. After that, from entry 3 to all the way to entry 10, we tried experimenting with different catalysts, starting with an acidic catalyst to metallic catalyst to transmetals. And we observed that copper iodide gave us the best yield. With the catalyst test, we tried the same reaction condition in the absence of an acid, but the yield dropped, which highlighted the importance of acid in the reaction. After that, we tried varying the reaction temperatures and also the solvent systems, and ultimately we fixed the standardized condition for this reaction as 10 mole % of catalyst copper iodide, the solvent system acetic acid and DMSO in 1:1 ratio and 140 degrees Celsius of temperature, which afforded our product an excellent yield of 92%. So, with the reaction optimized with our standard conditions, we exposed different kinds of substrates to our reaction conditions and developed a wide substrate scope of over 37 compounds. A few examples are mentioned here. From compound 1 to 6, we tried symmetric substitution on the R1 and R2 with both alkylic and phenylic rings and was successful. Compound 1 generated a beautiful crystal which was later characterized. In compound 7 to 12, the quaternary carbon here was substituted with different kinds of cycloalkyls. Following that, We tried an asymmetric substitution at R1 and R2 with a methyl and phenyl substitution. We also tried substituted arene groups with electron withdrawing and electron donating groups attached. After that, we tried attaching a highly complex aromatic molecule in a fluorine moist ester quaternary carbon and was successful. After that, we tried different substituents at the R3 position from compounds 19 to 22. All these examples have the thesis position of naphthol either occupied with a hydrogen or an electron withdrawing halogen. So, we wanted to see if the reaction could tolerate having an electron donating group at the thesis position. So, with that aim in mind, we tried developing compounds 23-25, but unfortunately, only a methoxy substrate at the C6 position of naphthol gave our expected product. Compound 26 is of particular interest because when a 2,6-naphthodiolic intermediate or derivative was exposed to a standardized reaction condition, a double CH cycloelectrification happened, generating a polycyclic framework with 8 rings. This could have a lot of applications in material chemistry because, as you can see, it's conjugated all the way from top to bottom. Right. So, we also expanded our substrate scope beyond simple naphtholic systems and included fluorinolic systems as well. We also tried the same on sessamolic systems, but unfortunately, a sesamol fused pyran did not undergo the thermal ring rearrangement as we expected. To understand the secrets behind the mechanism of the reaction and to check if the reaction proceeded through a radical formation, we introduced a radical scavenger into the reaction in forms of 3 equivalents of tempo, and after 2 hours, the expected product was isolated to 83%, which proved the absence of any radical in a mechanistic pathway. To test the scalability of the reaction, a gram scale synthesis was also performed, and after 2 hours, 80% of the product was isolated. In terms of post-static modification, when the bromide group at the C6 position of naphthol was coupled with para-tolyl boronic acid, which under Suzuki coupling reaction gave the coupled product in good yields. Yeah, so this is the proposed mechanism. The oxidized copper first coordinates with the Indian pi bond forming coordinate A, which underwent the cycloelectrification forming intermediate B, which underwent the demethylation releasing the copper and acetic acid to give intermediate C, which finally underwent the dehydrohalidation releasing the hydrogen iodide to afford the product in good yields. After that, the copper was oxidized back to copper 2 with the acetic acid, hydrogen iodide and oxygen iodide. So, to conclude, we have developed a simple and efficient method for intramolecular case sterilization of 18 sp2 carbon with a phenolic hydroxy group. Apart from expensive substrate scope, our method gives highly excellent yields in very less time. Finally, this work was published in the Journal of Organic Chemistry last week and ACS Journal. These are the people I'd like to thank for making this work possible for me. I'd like to thank the PJ Research Department of Chemistry, Farook College, and EFCS Organizing Committee for giving me this speech. Thank you.
Thank you, Jazeel, for the wonderful presentation.
Thank you for a nice presentation. And could you elaborate why copper iodide makes a difference compared to other salts?
Yes, sir, because as we were going to the previous report, we found that copper had the best possibility of coordinating with the pi bond. So that is the reason we incorporated that point in our mechanism. Among all the transition methods, copper has the best feasibility of binding with the pi bond.
And your starting material, is there any geometry related isomerism or chirality?
Yes, sir. So this bond actually, there is axial chirality on this bond. Because there is a helicity, because rotation on this bond is restricted, because there is no symmetric distribution about the bond. So there is a slight helicity. So because of that, there actually is isomerism on this molecule. And so when we have chiral carbon on this carbon, which is an asymmetric substitution, there is a possibility of diastereomer. It was observed in a NMR section. We had double peaks for all the. What do you take copper 2? Sorry, sir? What do you take copper 2? Copper 2 is the mechanism? No, the optimization. Yes, sir. You also use copper 2 copper 6, right? Yes, sir. What was the logic behind that? So, plus 2 oxidation state is the most common observed. So, what are we actually doing with this? Following it here, right? Yes, sir. Essentially pulling out the proton from the CH and from the. Yes, sir. So, what is the advantage of using copper 1 over copper 2?
copper one. So because
अगर the pay company is red, you think any other 20 copper one.
I cannot say.
I also start to see. Now my activity position is red but late. Sign of using no yet.
So it probably could be because there is a pi bond that is left. There is a pi bond that is present in the cyano substitution and the aldehyde substitution. Now, this pi bond could possibly form an interaction with the copper. As I said, copper has a high tendency to bond with pi bonds. So, because of that, the copper in the catalyst could bond with the pi bond present in the cyano and aldehyde group, blocking the reaction. But that pi bond is absent in the methoxy group, so the reaction went out.
How to trap them and how to understand this copper is actually bonded to this system. What methodology, what technique you can use?
The mechanism we proposed, unfortunately, we could not isolate any of the transition states to confirm our mechanism.
Without isolating the transition state, what is the methodology?
Because probably the IR studies. Sorry, sir?
And I was in a question. If I were to use copper extracurricular plus BF4 salt, it's a copper ion. You know, there's a copper one complex called Cu assembled four times. It's a BF4. If I were to use this, it's a copper ion. Will be the metal be enhanced or will it decrease? So it's like a like that. What I don't understand is that why copper iodide? Everybody is on copper iodide. I mean, that can be copper plus copper nanoparticles, copper chloride, copper whatever.
Yes, in the substrate scope, we actually tried a reaction with copper acetate, if I'm not wrong. Yeah. There is an entry with copper acetate and copper citrate. But they did give moderate yield, but a copper iodide complex gave an excellent yield. So maybe because the hydrogen iodide that is releasing is instrumental in oxidizing the copper back to copper 2.
I can add iodide later. Okay. I have one question. Always when you present these results, it's always interesting if the reaction doesn't proceed. And most people usually focus on reactions that proceed on the yield and always after better yield. I think sometimes it's good to look at it the other way around and to look at the cases when it doesn't proceed. Is it possible that you would co-crystallize copper 1 plus with those molecules that, for example, you can react to get an X-ray structure and read out maybe the interaction which you talked about, but to actually prove it, that stands behind the fact that the reaction doesn't take place.
So I'm talking about isolating the copper complex in the mechanism. Intermediate. Yeah. So we're talking about isolating isolation.
Those reactions which did not proceed.
Okay. So, for this, I did get a question. So, this is probably because of the presence of pi bond in the cyano substrate and the aldehyde substrate. So, that would coordinate with the copper present in our catalyst, blocking the reaction. And in the case of cetanol, the only reason I could see and I could observe was that at elevated temperature, this completely kind of broke apart. On the THC, there was no spot. So, there was no spot. We tried isolating. So, expanding on that, we did isolate